Hello, and welcome to this session about ethics in AI. My name is Tess, and I'm a data scientist and a software engineer at Microsoft. And I'm also very, very interested in ethics around AI, and I'm part of ethics groups to sort of determine what we should and shouldn't do in AI in Microsoft, and specifically in our group. And last year, a couple of researchers in LA came up with this model or this software to try to figure out if some crime was gang-related or not. So they published a paper called Partially Generative Neural Networks for Gang Crime Classification with Partial Information. Now, the partial in this case is that they base their decisions on text in the crime descriptions, and if they don't have text, then they generate some text. So right there, it sounds a bit fishy, I guess. But they also base it on something called the CalGang database, the California Gang-Related Activity Database. So this is obviously something that seems like a very, very useful piece of software to have. If you can classify if a crime is gang-related or not, you can put more scrutiny on these crimes, and you can put more efforts, you can make sure you track these people, and maybe look at the areas where they live and things like that, and kind of get rid of the gang-related crime and all. But what happens if you get it wrong? Like, what happens if you classify a crime as gang-related and it turns out not to be? In that case, not only the perpetrators, but also the victims will be labeled as gang-related or gang members. And they will probably be stored in this database, in the CalGang database, and get a lot more scrutiny from here on. And unfortunately, there are a couple of problems with this database, apart from someone being labeled as gang-related that's not. And that is, the fact that about 25% of the people in this database that the research is based on are in fact not proven to be gang-related. Most of them are Hispanic and Black from certain neighborhoods, and solely in there because they happen to live in these neighborhoods. But the problem is also that once you get into this database, you hardly ever get purged from it. And this database is used by companies that hire to determine if you should be hired or not. So it's quite consequential if you get labeled as an active gang member and you're not. And when they did audits on this database and found these things, that, for example, a lot of people in there are actually not gang related, they also found that 42 of the people in there are actually under the age of 1, out of which 28 have admitted to being active gang members. So when they presented this research at a conference, naturally they were met with a lot of questions. A lot of questions like, what did you do to fix the database, like the problems in the database before you used it as data for your model? And what did you do to make sure you didn't just assume that the crime was gang-related because there were Hispanics or Blacks in this zip code and whatnot? And the guy who presented it, he stood up and said, I'm just an engineer. Like, what do I have to do with this? And that one sentence is sort of what I want to talk about today. The sentence angered, well, a lot of people got angry by this, but it specifically angered this guy from Google called Blake Lemoine, who stood up and quoted a song by Tom Lehrer about a German rocket scientist called Werner von Braun, whose rockets were supposed to land on the moon, but unfortunately landed in London in the Second World War. So he said, so once the rockets are up, who cares where they fall down? That is not my department, said Werner von Braun. By the way, an awesome documentary too. But this, I'm just an engineer, I'm here to suggest that maybe we are not just engineers. We're put in charge not only with AI, but with everything we do as software engineers, in charge of some very, very consequential systems. Like, for example, systems that determine if someone's CV should or should not pass through to the next phase of interviews. So basically, should they get hired? Should they get insurance? Should they get loans? Should they live or die? Like real medical systems that determine who should get treatment or not. So we're not just engineers, we have a little bit more responsibility than that. About 2 years ago, probably a lot of you have seen this research that stated that, so Michael Kosinski created this research and basically said, with 50 likes on Facebook, I can tell you who you are better than your friends and sometimes better than your spouse. So he did this research to sort of scare or to show that with social media, you can do a lot of profiling. And someone picked up this profiling, Cambridge Analytica, and used this exact same research in order to win an election. By doing, if you went to Gary Short's talk, and this is what they base who they should A, B, and C test their ads on, this particular research. Now, later that year, he also published another extremely, extremely controversial paper called the AI Gaydar paper, or commonly known as the AI Gaydar paper. So in this paper, he claims that given just a picture of someone's face, he can determine what their sexual orientation is. Now, I can hear some thoughts in here think, well, maybe that's actually doable. Maybe you could actually do that. And once again, he did this sort of to scare and to say that this is something that people could do. We should be very wary that this type of thing could be out there. Now, so he also wrote in a lot of documents after this paper saying that he knew that what he, like the methods that he was using were wrong. So actually his work didn't really work the way it was stated in the paper, but he wanted to point out that someone could come in and do this. So a couple of things he did in this paper were he used data from dating websites where you're maybe a little bit more stereotypical than you would be in normal life. And his testing for accuracy was also a little bit dubious, but he found a couple of things. He found that, for example, if we look at from top left, so here's like the typical man who prefers women, men who prefer men, women who prefer women, and women who prefer, women who prefer men and women who prefer women. And he found like stereotypes like women who prefer men wear more makeup, men who prefer women are worse at taking selfies, like you can see their nostrils more in these composite pictures. But there is a lot bigger issue at stake here. And that's that we're classifying these as ones and zeros. Whether you're not on one end of the spectrum, one, a man who likes men. And on the other end of the spectrum, you're a man who likes women. And that's the only two classes that exist. Whereas in reality, there's a lot more to this. There is anything from bisexual, bicurious, someone who hasn't discovered what their sexuality is yet, or anything in between. So classifying things like this, even if we could, is very, very simplistic. And unfortunately, also very, very consequential. So right now, for me, for example, I live in Sweden, and if I get classified the wrong way, it doesn't really matter to me particularly. I already have, like grown up, I already have my life quite set. but if I lived in a country where being a homosexual was illegal, that would have a very, very much higher consequence for me, and especially in some countries where it's not only illegal, but it's punishable by death. So you can see how this can be used in some very, very bad ways. And even if you think like a country like Sweden, not too long ago, we're talking like a couple of decades ago, this was considered sort of a mental disorder. Luckily not anymore, but even still in libraries, it's still sometimes classified in like books about sexuality that's not super heteronormal are put in mental disorder categories, which you can see that having a classification like this has a very, very long tail, and especially when there is actually not a classification to be made even. Speaking of criminal, a couple of researchers, same year in China, came up with this paper that basically claimed that given your face, I can tell you if you're a criminal or not. Very, very useful. So they picked out some faces, 2,000 Chinese men, and just based on one face, they could say with 90% accuracy whether or not this person was a criminal or not. So the other data said about a third of them were criminals, and 2/3 were not. And you might think to get 90%, you would have to pick out some really, really hardened criminals, like Hannibal Lecter-style criminals. But no, in fact, only about 30% of them are violent, and the rest are fraud and is random things like that. So, has anyone in here gotten a speeding ticket? Have you? Yeah, I can see that on your face, actually. Or AlexNet could. Again, there are problems with this. First off, like the pictures that they used for the criminals were government-issued IDs, very stern, whereas the non-criminals were corporate headshots and a kind of present. So what they found was, in technical terms, the people who were non-criminals had this triangle between the nostrils and the mouth that had a certain curvature, over 30%, yada, yada, very technical. In reality, like these people were smiling and these people were not, and that's sort of what they found. And I kind of present like exhibit A of me being, yeah, you can see. The thing though was, just like in the case of your sexual orientation, this is a very fluid thing, and to say that you could say with 90% accuracy whether you're a 1 or 0, not only means that it should be super, super good, but it also means that somehow there is a line between criminal and non-criminal where my face changes. And the question is, does that change happen like when I was born? Because was I born a criminal? Or did it happen like when I stole that pen at the office? Like, how is this even supposed to happen? And 90% is also a very, very interesting figure, because at the time, this was using AlexNet, a certain architecture of neural networks, that at a time could determine gender in 86% of the cases. So they were doing pretty good with the 90%, I think. So the question is maybe not, can we do it? Because all of these suggestions that we can are quite flawed. And even if we could, the question is not can we do it, but should we do it? Should we really be classifying personal behavior, personal sort of personality based on faces? Is that what we should be doing? Kate Crawford, she used to be a researcher at Microsoft, and now she leads the AI Now Institute for Fairness and Accountability. She said, we're currently in the biggest experimentation of classification in human history. We've been doing this a lot before. We've been doing this through the ages. Since Aristotle, we've been doing classification based on facial features. But suddenly now we're doing it at scale and without anyone knowing. Because people don't have to come up and measure your face. They can just take a picture of you that's readily available somewhere or as you pass something and make a judgment on this scale. And you might think that this is sort of like a Black Mirror episode. Of course people are not doing this. Of course people realize that this is not doable, that you can't assess with 90% accuracy if someone is a criminal or not, if you can only assess sort of male-female with 86%. But it turns out people do. This is a real website where, based on your face, this website says you can determine your IQ, whether or not you're an academic researcher, a professional poker player, or a terrorist, using just your face. And you can clearly see where this could be used, right? Immigrations, customs, why not? Computer says you can. This is very, very scary because as soon as you make it into an algorithm and a computer application, people will trust it. Last year at NDC Oslo, my friend Bill Wagner was telling me a story how he and his wife were remodeling their house. So they went into a store and got a couple of 2x4s. And then they got to the cashier, and the cashier sort of scanned their 2x4s, and it wasn't showing up in the system. So he brought over another cashier, and he scanned the 2x4s, and they weren't showing up in the system either. And then a curious thing happened, because both of them, with the 2x4s in their hands, said, computer says, no, we don't carry these. We don't carry these, because the computer says we don't carry them. So with just making it into an algorithm and claiming that you have 90% accuracy of something, you're doing sort of like this sort of this accountability laundering, because suddenly it's not you as a person who's saying this, it's a computer, and the computer is kind of right, because a computer is just an algorithm, it's just math, it can't be biased, it can't pick up its own feelings about whether or not this is a criminal or whether or not this person has this personality trait. It's like, it's math. But unfortunately, it's not. Well, it is math, but it's math based on a lot of data that contain a lot of biases that we have. So I have to admit, I'm not a big Star Wars fan. Not at all. I can't tell one Wookiee from the next. So if you had Chewbacca and his wife and a couple of other Wookiees in the lineup, I would not be able to tell like who was who at all. And similarly, if I was in a situation and someone asked me which one of these 10 Chinese men was in the scene at the same time, I could not tell that, because I have not been exposed to enough Chinese men. Like, I don't have many Chinese friends, and I have a couple, but not enough to give me sort of like the knowledge of how to differentiate between them, especially under stress, for example. Because we all have this very, very strong in-group bias. I'm very, very good at determining who's who among European females. I know exactly. It's like the eye color, the hair color, things like that, things that don't apply to maybe Chinese men. I don't have enough training material. And in the same way, machine learning has the same problem. If it's not been exposed to someone outside of its group, it won't learn the features that you need to use to differentiate between them. So now, the question is, what is machine learning's in-group bias? So I do a lot of computer vision projects, and I help a lot of customers with computer vision. And computer vision and determining like objects, one object from the other, is largely based on this huge data set called ImageNet. That's one of the big data sets that we use. And basically, most other machine learning algorithms are derivatives of this, like transfer learning from this one database. And this database has a lot of like everyday objects of, or cats and dogs and tables and chairs and things like that. But unfortunately, it's derived, like I would say 70–80% of pictures taken in Europe and the US. Which means that if you look at like everyday objects from Africa, they will not show up in this data set. And it also means that if you look at a picture like this, it will classify it as baseball, right? It's only because this is what it knows. This is sort of what it knows, understands, and remembers. And now, recall that this is sort of what everything else is built on. In the same way, when we do face recognition, we've largely used a benchmark that's called faces in the wild, or labeled faces in the wild, where it's been labeled with who it is and how old they are and things like that. So labeled faces in the wild is a data set that comes from Yahoo News from 2002 to 2004. So it's 77% male, because the political hierarchy, or like the society hierarchy of who gets in the news is like that. So 70% of the pictures in there are male. In fact, most of the females in there are actresses, so lots of makeup, long hair, like very updone. 80% of the people in this data set are white or paler shades of white. And can you guess who the main person in there is? Like a person who actually makes up a good 5% of the data set. Any guesses? Yeah. George W. Bush. I guess now it could be Kim Kardashian, actually, but back in 2002 to 2004, it's George W. Bush. So this means that when we benchmark our face recognition, whether or not it's like Facebook, Google, Microsoft, whoever, they benchmark against this. So it's really, really good at recognizing George W. Bush. Awesome at recognizing George W. Bush. Unfortunately, less awesome at recognizing other people. So this is a data set, like many of the data sets that we're using, that's sort of labeled in the industry as male, pale, and stale. And it causes issues like this one. So Nikon, this is quite an old one, but Nikon was doing this AI software that was supposed to figure out if someone was blinking in a picture and then not take a picture. Fortunately, not tested for a large group of the population and didn't work for them. Or when I was using, and this still happens, when I use face recognition software, like, you know, how old am I, what am I? It comes up with male. I'm very happy about the 26, I have to say. I'm quite all right with, I'm even to the point where I'm like, I'm okay with that enough that I don't care about the other one. But it's a bit unfortunate, and this is because I don't look like the typical actress that are in these benchmark data sets. So I want to show a demo. Let's see if we can, yeah, this is going to work. So if we use, this is OpenCV, a very widely used library for doing all sorts of image recognition tasks or image tasks. And one of the things it has is it allows you to bring in models to do face detection, for example. And if we run this on an image, It has very, very nice accuracy. It can show the squares around the face of these women. But unfortunately, if you run it on a picture like this one, it does not even recognize the face as a face. And we can clearly see that this face is there. But unfortunately, the database did not contain, or the database that these models are targeted against, do not contain enough black women. So not only is she going to maybe be a male, but she's not even existing as a person. So she can't use the systems that you build on top of this type of model. This is a very, very scary proposition that we're creating software that's not inclusive enough for some people to even use. And the fact that she's wearing a mask in her hand that's white demonstrate this, because she's a researcher in AI. Her name is Joy Bulwamini, and she's doing a research around face detection, but she can't use face detection herself. So let's see. So what she's done is she's done some research on the largest face recognition or face detection softwares out there, and while they had like super good accuracy, like these have accuracies in like 99 something as far as like determining gender and recognizing your faces and things like that. When you split it a different way, in this case in the ways of female, male, and then she also used like a shade index of like how dark you were, she discovered that, for example, for the IBM solution, only in 65% of the cases did it detect the gender right for black women. Since then, a lot of things have happened. So she's, I don't know if she is now or she at least has worked for Microsoft, but she's changed the industry to the point where they're no longer targeting these labeled faces in the wild as far as benchmarking, but instead IBM generated a much more diverse data set to train and to benchmark against. So now we're actually pretty even Steven on all of the gender definitions here. So the problem with something like this, though, is that when you have a system like this that suddenly can't differentiate between Chewbacca's because it hasn't seen enough Chewbacca's, you get something like this. So this was in the UK, I think last summer, where this one guy, he was just walking down the street and the police came out, got him on the floor, like a piquet buzz, got him on the floor, and basically treating him as a very hardened criminal. But it turned out that what happened was, so they have CCTV cameras all everywhere doing face detection, but they happened to catch the wrong guy. Because to face detection, like, he looks a lot like many other people, because face detection hasn't, or face identification hasn't learned to differentiate between them. Now, this brings up a very different topic of perpetual lineup that I'll get to a little bit later. But for now, saying algorithms can't be racist because they're just math is just sort of like bias laundering, like taking it to an algorithm used to say that you no longer have bias. And this is not only in vision, but for example also in text. And again, this happens in systems that we all depend on, that we're all using sort of downstream in all our applications. So if you go into Google, and this will happen today if you do this, and you type in, she is a computer programmer and he is a nurse. And then you translate it to Turkish, which is a gender-neutral language, which means that we don't have he's or she's in here. Instead, we have the O. And then you translate it back, it will translate it back like this. And then you might go, okay, so this might be quite natural because most of the computer engineers are male. So it's like if I were to venture a guess, I would guess he. And most of the nurses are females, so I would venture a guess of she. So we can think that this is correct, but the way this is used downstream makes this not correct, because suddenly computer programmer is a very male thing. Like these have these definitions of gender or race or things like that ingrained into them. This is how the systems work. And the problem is that it doesn't stop here, because this, I mean, it's unfortunate for me, but we could think that this is actually how it's supposed to work. But what about this one? Translated to this. So this happens for all your words and everything. So all the biases that we've picked up in text are going to be coming through in everything you do. There are ways to debias these word embeddings. So this is an embedding is basically a description of a word that contains a lot of information, out of which one or two of the numbers together may mean female or male, for example. There are ways to debias them, but when you start to do technical things like debiasing them, like removing the male or the female, it's sort of hard to determine when you should stop or not. Like, for example, if we say computer programmer, maybe that should be debiased. Maybe that should be gender neutral. But what about something like colorblind? Should that be gender neutral? Or pregnant? Or you know, things that actually there is a real meaning in having gender or something in there. So it's a very, very difficult problem to tackle. Even if you think okay, so I see the problem, I can fix it by debiasing, but there is a question of if you should even. But if you don't debias and you use these systems or these word embeddings in systems like this one, this is an Amazon CV tool. Basically, it took your CV and then said, should this even go to an interviewer or not? And they found out that if it was something that came from a female, it was never going to a recruiter, no matter what. So they did a lot of slicing and dicing and said, okay, so let's remove the name, definitely remove, like if it says female or male, let's remove some schools that they went to, because some of them kind of have telltale signs. But even when it came down to the actual wording, things like using the word executed, it's a very, very male thing. I've executed a people or two, but I'm not putting that on my CV. And you know what I'm saying. So when you use something like this, it gets even problematic in the downstream case when you use like data from Google Translate or from these big systems that have this bias ingrained. Another problem, now totally different from bias, is something like this. I'm sure you've all been in this situation, bought all the laces, and yeah, no longer need laces. This is part of something called a confirmation bias bubble. So what this is basically when you take the results of a machine learning system and then you decide to use that as your only truth. Essentially, if you take the result that all computer engineers are male, and then you say, we're now only going to hire males, and you just basically perpetuate the problem and make the problem even worse. But in this case, for example, looking at your Facebook feed or even your Google or Bing search results, and depending on what you click on, that will now be your preference, and that will now be the only thing you see. The more you like something, the less you see of the things that you don't like. So we end up in these bubbles of the sort of like feeling that everyone is like us, and everything we search for will always be very tailored to us. So when we get into the real world and realize that someone actually thinks just a little bit different, and you go like, ooh, I had no clue that there was even, like, people that thought this totally different way because you've never been exposed to them. Or similarly, for example, on Spotify, you end up just listening to the same music over and over. So the question is, what can you do to break a bias bubble like that? What can you do to break the fact that you actually need some outside intervention so you don't end up being just more and more and more the same of yourself? So in the case, for example, in this case, and actually Bing and Google both do this. So typically if you search for a CEO, this is the results you're going to get. And then normally, like if you search for something, most people end up picking a result from one of the first 2 or 3, maybe 4 items and using that as the result. Which means that if you now go in and click on any of the people on the top 3 rows, you'll eventually end up with a system that is only ever going to show, in this case, male CEOs. But in order to prevent that, both Google and Microsoft and other search engines inject female CEOs, like the top female CEOs, into this to at least leave the status quo of what the world actually looks like as compared to what it would look like if we only had the majority option all the time. Now, is that a good or a bad thing? It's a political decision. It's not necessarily a technical yes or no answer. It's always going to be, like any solution to something like this, it's always going to be a political decision. Another type of confirmation bias bubble is, let's say you have a very high crime area. This is a place that's known for having a lot of crime, so you send a lot of police there because your machine learning algorithms tell you that this is where you should be sending all your people. Now they go through and report that, yeah, there was crime there, and suddenly you have even more crime reported from this one single location, which causes you to send even more people there, and more crime reported, so send more police, do more arrests, and suddenly you end up in this runaway feedback loop. So you need to sort of like be careful when you use a machine learning system for anything, that you don't end up in these situations where you only choose sort of like the top suggestions and never interject it with something else and end up with these bias bubbles. So to make errors, that's human. We all have biases. The reason why these systems have biases is not because someone was evil and entered this, that, and the other that we didn't want. It's literally because we've had these biases all along. Only when we're humans, to bias is human, but to put it into an AI system, we do it at scale and we propagate it and we cause these runaway feedback loops. Because when we bias as humans, we at least have like this check, this constant check that allows us to say, maybe we should be thinking a little bit different. But algorithms don't have that common sense of what we should be doing to sort of fix the situation. So bias in machine learning is an NP hard problem. There are so many variables to this. A lot of what we've been looking at here is female versus male, because it's very, very hard to exemplify with female versus male. But and in that case, you can go through and say, okay, so let me do the Joy Bulamini thing. Let me make sure that it works the same way for males and females. But what do you do for something like ethnicity? Is it like Caucasians against all other ethnicities? Is it In that case, you have a lot of different types, and it's a very, very fluid situation. And then even if you fix that, what do you do for like sexual orientation, political orientation, religion? Like, where does it stop? Does it stop where you think maybe what should we do for people that are live in like rural areas and urban areas, because maybe they get treated differently? There is always, like in any situation that you can come up with, there's going to be a minority there's going to be someone who's not very, very represented by the system. And in some cases, like with the face recognition, where it's like male versus female, it's not even a minority, it just happens to be a minority in your data set. And let's say we figure out that we have bias. Then what do? So we take like a loan system, and so we have a system that's supposed to tell you if you should get a loan or not. And then you say, okay, so let's say I have 30% females and 70% males that apply. What should the outcome be? Should the outcome be that we remove the gender? We say, let's not look at whether or not they're females or males, and let's just do our thing. But then you discover that maybe females still get less loans because they have some other issues, like they have less income. They've generally had a job history where during some years of this job history, they didn't have a job because they were home with the kids or whatever. So then you might think, well, what if we do like equal outcomes? So if we have 70-30, the results should also be 70-30. Unfortunately, that's also not a very, very good proposition, because what if all these 30 women had like no money at all, and all the 70% men had a lot of money, so they're clearly more eligible for loans. We don't want to sort of like take some people that clearly shouldn't get a loan from this area and give them a loan, whereas some people that should be getting a loan from this area, not give them a loan because they weren't filling up the quota. So then there is a question of, like, should we give them equal opportunity? So they should be treated equally based on if they have all the sort of prerequisites to get a loan or not. And deciding where on this scale you fall is, again, a very, very political decision. It's not a technical decision, but it's a decision that somehow we as software engineers are suddenly in charge of, right? So if it's this difficult, what do? Like, do we just give up? Because it just seems too hard. Well, I wouldn't stand here if I thought we should just give up. So instead, I'm suggesting that we look at it from a little bit different angle. And instead of giving up, look at what we can do to sort of mitigate the problems. So at Microsoft, we have these ethics boards that go through all our projects and figure out basically what could possibly go wrong. What's the headline that we don't want to have because of this? Like, what is the negative things that can happen, and how can we make sure that those things don't happen? So a couple of the things that we go through are looking and making sure that they are fair and inclusive. So this means that testing for the people that's supposed to be in our population as best we can, and making sure that things act the way we want, like whatever decision we take on how we want the outcome to be, that the outcome is actually like that. That is transparent, so this means that everyone in the process, from the software engineer to the product owner to the person who's using this, the person collecting the data, the person it affects, like the actual decisions, know how the decisions are made. So basically know what data is used for it and can control and test things. Sometimes it's not very easy to figure out exactly how machine learning got to the decision, but at least if you have the data, you can go back and make sure that the data itself and the decisions seem reasonable. And also be accountable. So someone needs to be accountable. It's not okay to say that the computer said so. Instead, if something happened, because something is going to happen, like bad things are going to happen, they will always happen. And then the question is, how do we deal with it? So having someone accountable and making sure it's safe and reliable so that we don't run into a runaway feedback loop. Instead, we have safeguards to make sure that we stay within certain parameters, that we don't have, like Tay, the Twitter bot, that suddenly went racist. Like, we have to have safeguards to make sure things like that doesn't happen. And then also, of course, ethically look at security and privacy to make sure that the data that you're giving this algorithm, it's not spread. So a typical example of this, apart from like the obvious security and privacy things, is things like if you have something that autocorrects and then suddenly pops up with words that you may use a lot, but that you don't want other people to know that you're using a lot, that might not be very nice if they show up in your autocorrect when you're in public places, for example. So, in general, thinking about how your software may be used downstream or may be used in general to make sure that you account for like the worst possible situation that could happen with this. When it comes to face recognition, for example, we have, at Microsoft, we have all these, sort of like we've determined a set of rules for when you can do this, specifically to avoid for it to be used in places like predictive policing, like the case we saw just a while back. Because the threat of sort of like a perpetual lineup of having CCTV cameras where you're always on a lineup and you're always watched and everyone can always see what you do is a very, very real threat. It's already happening, not only in the UK, but in the US and in a lot of cases. And we need to sort of, if you're building big systems that can be used in these cases, you need to put safeguards around where they can use. Another thing that you can do is create data sheets for data sets. So what this means is, for example, for the labeled faces in a while, that was never meant to be a benchmark for these kind of systems. In fact, if you would have looked through it and found out how it was gathered, and a couple of things like sort of what the parameters look like for this data set, what the like how many male and how many female and that kind of stuff, it would have never been used as a benchmark for this. So understanding how the data is gathered, registering that, and also setting sort of similarly to saying data sheets for electrical circuits, determining under what circumstances someone can actually use this data, or at least describing it to make sure it's not used the wrong way. There's also some very nice tools to use for like fairness and inclusion checks. So this is from the Google What If tool, where you can label your data, for example, that these are people with these ethnicities, these are people with these, whatever it might be. And then you can test your algorithms and your models independently of how they were generated. You can test them and see how they fare in different scenarios, how they fare for different groups of your population. And then for the transparency, there is also, and this is something that's highly on the rise, different systems or different libraries to understand how networks come to the conclusions that they come to. So this is from a Lime database, where the canonical test is you have a set of dogs and a set of wolves, and it came up with a model that was like super accurate. Like it could almost in every case figure out whether or not it was a dog or a wolf. But then when you take it through Lime, you can find out that this was what it made the decision based on. Yeah, and then you think like, okay, so maybe while it was accurate for this particular test set, detecting snow is not exactly what we want our model to do. So making sure to run it through these interpreters and things like that to determine how it actually came to the decisions to make sure that it fits with common sense. And then when we look at predictive policing, which we shouldn't ever be doing predictive policing, instead looking at detecting versus predicting. So this is from a case that I was working recently where we look at cameras from stores and try to figure out if someone is shoplifting or not. So when we look at the shoplifting cases, we noticed that they were covering their faces, they were usually alone, men 20 to 40, wearing hoodies, and using like certain poses for shoplifting. And if we would have just built an end-to-end model on this, trying to say, is this a shoplifter or not, we would have very likely detected everyone who was a man 20 to 40 wearing a hoodie covering their face is a shoplifter. Obviously not really correct. So when so actually you can't use even the covered faces or alone as a predictor. Point being that you should never predict that someone is going to shoplift, because that's always going to give you a lot of false positives, and it's not really even indicative of the actual action of shoplifting. Instead, you need to be careful and look at predicting instead. So looking at, for example, the poses, because that's a real indicator of the action that they took. And this is a system in China that's in use where they use facial recognition to determine if someone was jaywalking, and then automatically text them a fine, which, yay. But it didn't really work out the way they wanted to, because this lady got a whole lot of fines. Like, I don't think she can even use her phone. But so obviously, whenever the bus passed, she got a fine. So there will be things that go wrong. No matter what safeguards you put in place, there will always be things that will go wrong. And the question is, for you, is how do you safeguard against that and deal with the errors? And one very common thing to do is put a human in the loop, and this is something that's preferable in most machine learning cases until you're very, very secure that it works the way it should. So if you're going to be detecting that someone is shoplifting, don't actually, like, I don't know, sound a bar when they leave, but have someone that can actually look at the footage and determine if that's what actually happened, and then tap them on the shoulder. Because if you go through and tap them on the shoulder without any human intervention, then you'll end up accusing someone, and even the accusation is quite a negative thing. Like taking this guy in the UK and putting him on the floor and treating him as a criminal is a very, very detrimental thing for a person to have to live through. But all in all, when all is said and done, the last thing I would encourage to do is speak up. When you see something that doesn't feel right, that doesn't feel like this should be what we're doing, do speak up. Because we're not just engineers. We are the guardians of our future. Thank you.